The 4 Electronic Flight Instrument System (EFIS) displays provide the pilots with flight data to help them operate the aircraft in a safe and efficient way. Flight parameters are displayed on primary flight displays (PFD), while navigation data is displayed on navigation displays (ND). Each pilot has an EFIS control panel to select what is displayed on the EFIS screens. The EFIS control panels are divided into 2 sections, one section associated with the PFD and the other with the ND. The Flight Control Unit, FCU, is located in the middle of the glare shield. The FCU is one of the interface units between the pilots and the autoflight system. The full use of the FCU will be covered in the autoflight modules. There are selectors on the FCU which will affect the indications seen on the PFD and ND, and it is only these selectors that will be discussed in the EFIS modules.
The selectors, with associated indications, are provided for speed, heading track, altitude, vertical speed flight path angle, FPA.
The metric altitude push button is also part of the altitude area. This push button is used to display the selected altitude in meters on the permanent data part of the system display. As an option, the selected and actual altitudes in meters on the PFDs. You will see how all these selectors affect the EFIS displays in the modules that follow. The 2 chrono push buttons located on the glare shield control the associated chronometer display on the NDs. The push buttons operate like a normal stopwatch. In this module, we have introduced you to the Electronic Flight Instrument System. In the next modules, we will look at the PFD and the ND in greater detail.
PFD displays all the normal primary flight indications: attitude, airspeed, altitude, vertical speed, heading and track. Notice that the yellow reference indicators are laid out in a classic instrument T configuration. The PFD also displays other information. The upper part of the display is used to provide information to the pilots associated with the selected guidance or with the managed guidance. The area is known as the Flight Mode Annunciator FMA. You will learn more about the FMA in the Auto Flight modules.
A Flight Director FD push button on the EFIS control panel enables the pilots to switch the Flight Director display on. Notice that there is an indication on the FMA when the FDs are switched on. Caution: both FDs must be switched on or both off. You should never fly with only one Flight Director selected on. When below 2,500 feet, a digital radio altimeter is displayed. In this module, we will concentrate on the primary flight indications. Let's start with attitude.
Attitude information is shown at the center of the display. The attitude indicator works in the normal sense. The pitch scale has white markers, as shown. Beyond 30 degrees, large red arrowheads show the direction to move the nose in order to reduce the pitch. The roll scale is displayed at the top of the indicator. The yellow triangle shows the 0 and the white markers indicate 10, 20, 30 and 45 degrees of bank. The aircraft is represented by a fixed symbol, in black and outlined, in yellow. Note, if V-bar's option is installed, the aircraft symbol is, as shown. The roll index triangle moves against the white fixed scale, showing the current bank angle. In this example, the aircraft is in a 20 degrees bank turn to the left, with the nose-up pitch attitude of 10 degrees. Below the roll index is the side slip index. This index moves to indicate lateral acceleration on ground and side slip in flight. It replaces the old-fashioned slip ball. When this index is centered with the roll index, the side slip equals the side slip target for optimum aircraft performance.
The pilot flying must use pedals to reduce side slip to 0. If the base of the pyramid is to the left, use your left foot to center the pyramid. If the base of the pyramid is to the right, use your right foot to center it.
If an engine failure occurs in takeoff or go-around configuration, the side slip index changes from yellow to blue and is called beta target. For more information, refer to the A320 Normal Law and Protections module. When the Flight Director FD push button on the EFIS control panel is selected, FD indications are superimposed onto the attitude indicator. The vertical line is the Flight Director roll bar, while the horizontal line is the pitch bar. Let's look at an example of the FD in use. In this example, the FD is directing a pitch up and roll to the right. Once the aircraft has achieved the required pitch and bank, the FD bars will once again be centered. Note, if V-bar's option is installed, the pitch and roll indications will be as shown. Also, after starting the first engine, a white cross shows the sum of side sticks orders, and white corners show the max deflection limits. Also, when on ground, or below 30 feet radio altitude, a ground roll guidance command bar is displayed, provided a localizer is tuned. It shows the flight director yaw orders to keep the runway centerline. The speed scale moves behind a fixed yellow reference line and triangle. In the example shown, the indicated airspeed has stabilized at 250 knots.
When the aircraft is accelerating or decelerating, a speed trend arrow appears. This arrow shows the value that will be attained in 10 seconds if the acceleration remains constant. In the example shown, the aircraft will decelerate to 240 knots in 10 seconds. The use of the speed trend arrow will be demonstrated during your simulator training. When the Flight Management and Guidance System, FMGS, is controlling the airspeed, a magenta target airspeed triangle appears. This is normally referred to as the managed speed. In the example shown, the managed target airspeed is 240 knots, and the aircraft is decelerating towards that speed. If the target airspeed is selected manually, a blue triangle appears. This is normally referred to as selected speed. In the example shown, a selected airspeed of 260 knots has been set, and the aircraft is accelerating towards it. To look at the various other indications on the airspeed scale, We will run through a typical flight profile. We will assume a departure with the flaps in position 2. You will learn about the various flap and slat configurations in the flight control modules.
On the MCDU Performance Takeoff page, the crew inserts V1, VR and V2. The upper part of the speed scale shows V1 in blue numbers and V2 in magenta numbers, as long as they are off the scale. Notice the related indications when V1, VR and V2 are visible on the scale. The pilot non-flying on OSIS.
V1.
Then, at VR, the liftoff must be performed. After liftoff, the speed stabilizes at V2 plus 10, because that speed is the flight director reference in SRS mode, as shown on the FMA. The F symbol, corresponding to the computed minimum flap retraction speed, and the VFE next appear, because their values are visible on the scale. Also, few seconds after liftoff, the VLS, VAlpha and VAlpha Max are displayed. For more information, refer to the Flight Controls Normal Law and Protections module. At acceleration altitude, the climb phase automatically activates, shown by the change on the MCDU and on the FMA. Also, the target speed jumps to the climb speed. Notice that, since that speed is beyond the scale, it appears above the scale, in magenta when managed by the FMGS, or in blue if selected on the FCU. Then, the aircraft accelerates towards the target speed, as shown by the speed trend arrow. When the current speed is at F speed, flaps 1 selection must be ordered. After flaps 1 selection, the S symbol appears with the new VFE next, when they are visible. Note, the Vmax also appears on the speed scale when it is visible. Vmax is now VFE for the flaps 1 configuration. At S speed, flaps 0 must be ordered and selected. When in clean configuration, the green dot speed is on the scale and corresponds to the best lift-to-drag ratio. Note, the target speed triangle will be on the scale when it is visible. Also, Vmax is now VMO/MMO. Notice that, when the speed stabilizes at 250 knots, the target speed is in line with the speed reference line. Remember that, a target speed is in magenta, when managed by the FMGS. In blue, when selected by the pilot on the FCU. Then, when a new target speed is managed by the FMGS, or selected on the FCU, the aircraft accelerates again, towards this new target. Also, when the current speed in Mach is above 0.5, its number appears at the bottom of the speed scale. Note, Vmax appears when it is visible on the scale and is VMO/MMO. Also, green dashes indicate the overspeed protection limit. For more information, refer to the Flight Controls Normal Law and Protections module. While climbing, the speed stabilized but the Mach continues to increase towards the Mach target managed by the FMGS. Also, when above 25,000 feet, the VMO limit at 350 knots will change to MMO limit at 0.82. Note, the bottom of the red-black band will move down, because the maximum Mach is constant, while the related speed is converted with the altitude, as shown on the chart of the FCOM LIMP 13 section. In the example shown, when the selected altitude of 33,000 feet is reached, the related Vmax and the current speed target, relating to the Mach target, are as shown. When a managed descent is initiated, a computed target, with an upper limit target and a lower limit target, are on the speed scale. Note, on the altitude scale, a green dot will indicate the deviation between the computed descent profile and the current one. If the descent is initiated before reaching the computed top of descent, the speed will decelerate to the lower limit target until reaching the descent profile. If it is initiated after the computed top of descent, the speed will accelerate to the upper limit target until reaching the descent profile. If it is initiated at the computed top of descent, the speed will be on the target. Following initial deceleration to 250 knots, and providing the altitude is below a threshold, which depends on the FAC version, there is an indication of the next flap limiting speed. When it is visible, this corresponds to the Vmax for flaps 1 selection. Green dot speed may be also visible. When an FM approach phase is activated, the target speed jumps to the V approach and commands a further deceleration to green dot speed. When the current speed is below the VFE next, or has stabilized at green dot speed, flaps 1 can be selected.
Once the flap lever is in position 1, S speed, VFE next, and the flap limit speed indications will appear. The speed will decrease towards S speed.
When the current speed is below the VFE next, or has stabilized at S speed, flaps 2 can be selected. Once the flap lever is in position 2, F speed and a new VFE next will appear. The flap limit speed indications will move. The speed will decrease towards F speed. Notice that the V approach target speed is now on the scale. When the current speed is below the VFE next, or has stabilized at F speed, flaps 3 can be selected. Once the flap lever is in position 3, a new VFE next will appear. The flap limit speed indications will move. Then, flaps full can be selected. According to the wind conditions, which may vary, during approach, the target speed will be adjusted between the V approach and the VFE of the related flaps configuration. The wind, which has been entered on the performance approach page, will be used to compute a minimum energy level. This minimum energy level relates to the ground speed the aircraft will have at touchdown and is called ground speed mini. There are indications associated with speed and angle of attack protections. These protection indications will be discussed in the flight control modules. Once the aircraft lands, all additional speed indications are removed, apart from the speed trend arrow. When the 3ADR cannot provide the airspeed information and only if they have been switched off, the airspeed flag is replaced by a backup speed indication based on an angle of attack and on the flaps configuration. Note, when not in clean configuration, it changes as shown. For additional information, refer to ATA34, Navigation Aider's Presentation module. Let's now look at the altitude indications.
All the indications associated with altitude are located on the right-hand side of the PFD.
Like the airspeed indication, a gray analog altitude tape moves behind the digital display. The altitude window will change from yellow to amber when the aircraft deviates from the FCU selected altitude, which is displayed in blue as shown. During a managed descent, a green dot will indicate the deviation between the current descent profile and the computed one. If there is an altitude constraint on the managed flight plan, the FMA alt indication and the target altitude change from blue to magenta. Notice that, when the altitude is below the transition altitude, the standard indication pulses, alerting the pilot to set the QNH, or the QFE by pushing the baro knob. A red ribbon to the right of the altitude scale represents the ground reference, based on the radio altitude information. Note, it appears when the radio altitude is below 570 feet. Also, the top of a brown ribbon on the altitude scale represents the landing elevation provided by the FMS database. The vertical speed indication is displayed as shown. Note, the current vertical speed is 2,700 feet per minute in climb. If the climb must be stopped, the vertical speed knob must be pushed. The target is shown on the FMA and can be FPA or VS according to the selection done by the heading vertical speed track FPA push button. When the vertical speed reaches 0, orders are given to maintain it. Note, the constraints are disregarded. If the VS, FPA knob is pulled, the current FPA or VS is displayed on the FMA and on the FCU. On the PFD, if the vertical speed is too excessive, the vertical speed indications change to amber. For more information, refer to your documentation. Note, if the metric alt push button has been pressed, the selected altitude in meters will be displayed at the bottom of the SD. Also, as an option on the PFD, the selected altitude and the current altitude in meters can be displayed. When there is a TCAS resolution advisory detection, the vertical speed scale becomes rectangular, and orders to fly the green are displayed as shown. For more information, refer to the ATA34 TCAS presentation module. When the 3ADR have been switched off, a backup altitude scale is shown. For more information, refer to the ATA34 EFIS Presentation module. When the aircraft lands, the vertical digital indication disappears when it is less than 200 feet per minute. When the aircraft is on ground, the red ribbon is in the middle of the scale and the vertical speed needle is at 0. Note, the brown ribbon will disappear when the speed is below 80 knots. We will now look at the heading scale. The heading scale displays a conventional compass.
The gray scale moves against a fixed yellow line, which represents the center line of the aircraft. In the example shown, the aircraft is heading 091 degrees. The small green diamond represents the aircraft track, and it is normally referred to as the track diamond. In the example shown, the track is 094 degrees, which means that the aircraft has 3 degrees of drift to the right.
A selected lateral target will appear if the related knob is pulled. It can be displayed by a blue triangle, which is positioned on the actual heading in heading mode, or on the actual track if in track mode. A blue figure on the appropriate side of the compass scale if the FCU selection is out of view on the scale. There's a direct relationship between the heading scale and the small white ticks on the horizon line of the attitude indicator. As the heading changes, the ticks move to stay in line. If the FD bars are removed, a blue line appears on the horizon line, indicating the selected heading or track. Now, let's look at how ILS information is displayed and in particular concentrate on the compass scale. When the approach has been selected, an amber ILS indication flashes on the PFD, as long as the LS push button is not pressed on the EFIS control panel. Notice that the lateral and vertical deviation indication scales and the ILS information are now displayed. Note, if the tuned ILS has a DME, the related distance is also shown.
A magenta diamond represents the localizer. When the ILS front course is within the compass scale, it is displayed as a magenta dagger. In the example shown, the aircraft is established on the localizer, and the glide slope indication has appeared in the form of a magenta diamond.
The aircraft is now fully established on the ILS approach.
You will be given more information on the ILS system, the flight director, the radio altimeter, and the flight mode annunciator indications later in the course. Now, let's look at another useful indication available on the PFD, the Flight Path Vector, FPV, called the bird.
The FPV can be displayed on the PFD by pushing the Track FPA button on the FCU. It shows you what the aircraft is doing in relation to the world. It is an indication of the aircraft flight path. It is not a director. The green symbol, sometimes called the bird, represents the aircraft. The attitude indicator represents the world. Let's look at the FPV in a bit more detail. When the aircraft heading and track are the same, the FPV and the track diamond are in line with the heading marker. So, these indications mean that the aircraft is not drifting. As the aircraft is flying level, the FPV is on the horizon line. So, the flight path angle is 0, with a pitch attitude of 5.1 degrees. When the aircraft descends, the FPV is positioned on the related flight path angle, as shown here, on -5 degrees. As a result of wind from the right, the aircraft is drifting to the left. So, the FPV is positioned on the related track, as shown here, on 220 degrees. If the FD is on, the related orders are shown for the selected track and the selected FPA. Here, a right turn to track 235 with the FPA at 0.
The navigation display, ND, can present the pilots with a lot of useful data to assist in the safe operation of the aircraft. Because the ND gives the pilots a visual presentation of where the aircraft is in relation to airfields, nav aids, etc., the operation of the aircraft is also made easier. In this module, we will use the captain's ND. There are 5 display modes available on the ND. They are selected by the mode selector on the EFIS control panel. There are 3 basic navigation display modes, which display in the background a 360-degree compass rose. Note, for training purposes, the other information has been dimmed. A 90-degree segment arc, a map plan with the north at the top. Before moving on to look at the individual modes, Let's quickly look at some common information. The ground speed GS and the true airspeed TAS are permanently displayed on the top left corner. Below the speed indications is the wind data, wind direction, true north, wind speed, and an arrow to indicate the wind direction with respect to magnetic north. Here, wind from 60 degrees at 52 knots. The aircraft magnetic heading is given by a fixed yellow lubber line against the moving compass rose. The selected heading or track, if bird is selected on, is shown by a blue triangle or blue numbers, if out of display range. This is similar to the PFD. Actual track is depicted by a green track diamond. Range marks are displayed by white dotted lines, while range values are depicted in blue. The display range can be adjusted using the range selector. Select 320-mile range. You can now see more of your flight plan and that the range values have changed accordingly. Let's study the ND individual modes.
The ROSE ILS mode is a raw data mode, providing standard localizer and glide slope deviation bars. Note, the full runway name of the MCDU selected approach will be displayed if, in the related FMS phase, the along track distance to destination is less than 250 nautical miles.
Other information is displayed to assist you. An ILS course pointer, ILS information. Select ROSE VOR mode.
The ROSE VOR mode is another raw data display. On the display, there is now a course pointer and a lateral deviation bar for the VOR. In this case, VOR 1. To have this display, a course must have been selected on the MCDU RadNav page. Like ROSE ILS, the information about the tuned frequency, the selected course and which navade, here PA, is displayed in the top right-hand corner. Also the MCDU selected approach type, VOR or GPS, is displayed as shown. Let's now display the VOR bearing pointer. Select VOR 1.
No, click on ADF VOR Selector 1.
Notice that there is a white VOR bearing pointer and VOR information associated with the pointer. This information is available even if a course hasn't been selected on the MCDU RadNav page. The number 1 pointer is represented by a single line. Let's change the selection on the EFIS control panel to display ADF 1 instead of VOR 1. This is achieved by moving the number 1 ADF VOR selector to ADF. We will do it for you. The white VOR bearing pointer has been replaced by a green ADF bearing pointer. The VOR information on the bottom left of the display has been replaced by ADF1 information. Notice that the selection of the pointer has not removed the deviation information for VOR1. We will now display the ADF2 bearing pointer by selecting ADF VOR Selector 2 to ADF.
The ADF2 bearing pointer is now displayed represented by a double-lined arrow. At the bottom of the display, there is information on the selected nav aids. Notice that in common with most things on the aircraft, It is number 1 on the left and number 2 on the right.
Notice the tiny underlined M beside the nav aid information, which indicates that each ADF has been manually tuned by the pilots on the MCDU RadNav page. You will learn more about the nav aid selection in the A320 navigation chapter. To see the effect of the ADF VOR selectors, click on the forward arrow to select both VOR bearing pointers on. The two white VOR bearing pointers are now visible. As you can see, on the RadNav page, the VOR1 is auto-tuned with its course manually entered, and the VOR2 is manually tuned. You have seen the two raw data displays. Now, let's look at the ROS-NAV display. A map view of the area surrounding the aircraft is now displayed. On the EFIS control panel, the range selector is set at 80 nautical mile. It is the distance from the bottom to the top of the compass rose. The green line represents the flight plan. It will be studied in the A320 Auto Flight chapter. The information contained in the top right-hand corner of the display relates to the waypoint. The information is track to waypoint, distance to go, ETA, estimated time of arrival at waypoint. In this example, the waypoint is Papa Alpha Sierra, and is also displayed on the map view. Note: as the waypoint is a tuned nav aid, it is in blue instead of in white. The normal mode for the cruise phase is the arc mode. Click on the forward arrow to select the arc mode with the range of 160 nautical mile.
Using the push buttons at the top of the EFIS control panel, additional information can be displayed. For example, airports that are in the displayed range. Select Airport.
A green light illuminates in the push button. On the display, the airports contained in the aircraft's database and within the area are shown. This is a useful feature when considering diversions. We have pressed the NDB key for you. All the non-directional beacons contained in the database and within the display range are shown. We have pressed the VOR DME key. All the VOR beacons contained in the database and within the display range are shown. We have selected waypoint key. The display has started to become very cluttered now that all the waypoints are shown. We have turned the range selector to 44U. As you can see, the display is a little less cluttered. Now, let's look at the final display mode. Select Plan Mode. In this mode, the flight plan legs are shown on a true north-orientated map. The center of the display is a waypoint. The aircraft is displayed in relation to the waypoint. In the example shown, the display is centered on waypoint Papa Alpha Sierra, and the aircraft is heading towards that waypoint. Waypoint has been deselected. Now let's increase the range to 320 nautical miles. We have turned the range selector. Since plan mode is centered on a waypoint, the aircraft symbol may or may not be displayed. To demonstrate this, we have shifted the display for you and centered it on the waypoint Golf Echo November. Notice that the aircraft symbol has moved towards the top of the display.